FST students, here's a little summary review on lesson 4.2, which is operations on functions. When we're talking about operations, we're just talking about addition, subtraction, multiplication, division, the main four, and then we're going to be talking about something called the composition of functions. Most of what we're going to do, you've done already, but when we're talking about addition, which can be written as f plus g of x, which means the same as just f of x plus g of x. You basically just combine like terms, like we always have. In subtraction, which can be denoted as f minus g of x, or f of x minus g of x, then we're going to add the opposite. Important to distribute the negative, combine like terms. In multiplication, which can be written as f times g of x or f of x times g of x. You can distribute FOIL however you need to multiply those combined like terms, and that would be your result. Division. Division can be kind of confusing at sometimes because you think you can do more than you can, but we're just dividing f by g of x, which is f of x divided by g of x, remembering that g of x, the denominator, cannot equal 0. And then you just simplify when everything is factored completely. Sometimes things will cancel, but in a lot of cases there's nothing you can do, and it's just f of x over g of x simplified. All right, a couple examples here. So I've got f of x to be 3x minus 4 and g of x to be 5 minus 2x. So if I'm going to add f plus g of x, I'm going to take 3x minus 4, f of x, plus the 5 minus 2x. I'm just going to combine like terms. So I've got 3x, take away x, which is x. I have negative 4 and a positive 5, which is plus 1. If I'm subtracting, order is important. And I'm going to add the opposite, making sure you take the opposite of both of these terms. And then it's simply an addition problem. We're going to combine like terms. 3x and 2x is 5x. Minus 4 and minus 5 is minus 9. Multiplication, we're going to take 3x minus 4 times 5 minus 2x. Here we've got two binomials, so we can FOIL this. So I'd have 15x. Outside terms would be a negative 6x squared. Inside terms would be a negative 20. And my last terms would be a positive 8x. Combining like terms, and also putting this in standard form, I'd have a negative 6x squared. I have 15x and 8x, which is 23x. And then the minus 20. And these would be your final answers there. For division, we're going to take 3x minus 4 divided by 5 minus 2x. And as you notice, there's nothing you can do. If you can't factor the top or the bottom, so nothing cancels here. And then the only thing you have to show is that x cannot be, because the denominator cannot be 0, the 0 of that would be a positive 5 halves. Here's another example. Now we've got a quadratic, and then we have a linear. So first of all, again, we're going to add these. So I'm taking f of x plus g of x. Combine like terms, I'd have x squared plus 6x plus 9. Subtraction, so now I'm going to take x squared plus 5x plus 6. I'm subtracting x plus 3. So now I'm going to add the opposite of each of these terms. When I combine my like terms, I'd have x squared plus 4x plus 3. Multiplication. So now we're taking a quadratic, which has 3 terms, times x plus 3. So now distributing, I'd have x cubed plus 3x squared plus 5x squared. I'm going to keep those together because they're like terms, plus 15x plus 6x plus 18. Combining these, I'd have x cubed plus 8x squared plus 21x plus 18. In dividing these, I'm going to take x squared plus 5x plus 6. I'm going to divide this by x plus 3. Now in this case, if you do factor the top, which does factor, you have x and x. Both signs will be positive. We have 2 and 3. Then you can see, since it's completely factored, these could be canceled. So our expression would equal x plus 2. We'd still have to say that x cannot be negative 3. A couple more examples. So we're adding, we've got x squared minus 2x. We're adding to it 3x minus 2. Combine like terms, I'd have x squared plus x minus 2. Next one's subtraction. Make sure we're keeping these in the proper order. And as we've done before, we're going to add the opposite. When I combine like terms, I'd have x squared minus 5x plus 2. Multiplication. So I've got x squared minus 2x times 3x minus 2. Here's another case where you've got two binomials, so we could use just the FOIL method. So I've got 3x cubed minus 2x squared minus 6x squared as my inside terms plus 4x. Combine like terms. And there's my product. Division here, I'm going to take x squared minus 2x. I'm going to divide by 3x minus 2. This one here, you can see you could take an x out of the top, but that would leave you with x minus 2. Nothing would cancel. So that's basically our quotient there. And then we'd have to say that x cannot be a positive 2/3, because that's what makes the denominator 0. Now the last thing is composition of functions. This is denoted by an open dot, f circle g of x, which stands for f of g of x. This means I'm going to input g of x as my input into f. And order is very important here. So in this case, I have f of g of 2. I can do g of 2 first. So this is just putting 2 into g, which is going to be 4. 3 times 2 minus 2. Then I would do f of 4, which would give me 2 times 4 plus 1, which would be 9. Next one here, we've got composition. This is g of f of x. This means I'm going to put f of x into g. So putting f of x into g means I'm going to put this function as an input into g. So I'm going to have 3 times 2x plus 1 minus 2. I can distribute, combine like terms, and this would be the composition of those two. The next one here is the same thing, but it's in different order. So here you can see we're going to put g of x into f, g of x function into the f function. So I'd have 2 times 3x minus 2 plus 1. And then again I can distribute, combine like terms, and I have that composition. And you can see they are different answers there. Here's another example. Here I'm doing f of g of negative 2. Order is important, so I do g of negative 2 first, put negative 2 in for g, and that gives me a negative 11. Then I put negative 11 in for f. I'm going to square negative 11, which is 121, minus the 3 would be 118. The other way around, now I'm doing g of f of negative 2. I'm going to put negative 2 in for f. Square of the negative 2 is 4, minus 3 is 1. So now I'm doing g of 1, which is 4 times 1 minus 3, which is still 1. F of g of x, this means I'm putting g of x into f. G of x into the f function. So I'm going to have 4x minus 3 squared minus 3. I can simplify this. I could write this out twice and FOIL, but I could also use schmads. If you remember schmads, we'd square the first term. We're going to multiply and double. And then we're going to square the last term. And I've got the minus 3. I combine my like terms. And there's that composition. Last one here, same thing, doing it the other order, putting g of f of x, so f of x into g. So it'd be 4 times x squared minus 3, minus the 3. I can distribute, combine like terms, and I have 4x squared minus 15. So I hope this helps you in completing that 4.2 Google Classroom assignment.